Good evening. From the theme of the seminar, I would like to share our experience on automation and application of the sensors in our mill. This is our commitment. We adopt QEEGHS policy, which stands for quality, environment, energy, occupational health and safety. And we are certified for the same from ISO. We make element chlorine-free papers only. Here we would like to share to automation in of the key drive for companies. It shows starting from early 2002 till date. So it's represent after the 2000, the automation gradually increased in our mill. So it is a main pillar of the automation is a main pillar of company's growth also. It reflects. We would like to share our case studies under the categories of cost saving benefit, safety enhancement, and the troubleshootings. So these are the topics, case studies. Let us start with cost saving measures for implement the gamma detections. Usually, radiations are used in non-contact type measurements. We are using in a Gobal 60 gamma source in our mill for the chips level measurement application a digester with a GM tube detector. What is the problem here is the Gobal 60 have less amount of half-life period. So the 5.3 years only the half-life period. The GM tube, it receives also which radiation is emit from the source, the one pulse received to the detector. So whenever the source is reduction the half-life period, also the GM tube also the intensity low. This source, this type of in such scenarios, replacing the source is not suitable way for us because the cost is too much of high. Then other thing, the gamma source lead does not go to zero. It emits some radiation also here. So we change over the detector. From the GM tube, the replace to scintillation counter. What is the principle of scintillation counter is here? If the emit of radiation 1 means the pulse detector receive the detector, it multiplied by the multi-photo detector and emit the photons to the light signals. So we can use here the scintillation counter of low intensity rays. So the purpose of benefits here, detection is low intensity. We have saved up to 45 lakhs of one-time investment with the procurement of scintillation detector without procurement of the gamma source. So next we go with the e-server. We are taken the next step by sharing the operational parameter from DCS to across the mill to know the real-time plant status at any point of time shows. So this picture is reflect in our SBB mill. We are connect all DCS page in a main page. All the plant means recovery soda recovery plant, pulp mill, paper machine, stock, everyone. Now we include the power boiler also include the e-server. So every page here the shown by the e-server. The network configuration, how to implement the e-server means all the various plant data DCS connected to the e-server with via one unique IP address to configure the all data to the e-server. Then the e-server is connected to our company LAN network with the protocol of firewall protection and network segmentation. Via we use the DCS data to the e-server. Then the data is all connected to our mill network. We can easily view at any point, at anywhere across the mill network. So this type of implement shows our e-server. Here, this is our plant overview. We can see able to all the plant DCS at the any place of the at any time current status data. So real-time plant status can view by higher official management also it can be used. We can move the next one of case study. It's a troubleshooting. We know the FIFO block. We know all of very well FIFO. What is represent? It's a first in, first out. So how and where to implement the DCS, this is our beneficial purpose. In DCS purpose, we are all using lot of pumps and valves. To the safety purpose, we used multiplex and lot of interlocks to safety purpose. With such a scenario, we face the problem, which cause of the particular reason of the pump or equipment to be failure is one of the reason. So identify the particular reason of cause, we implement the FIFO block. In this case, we faced during the plant startup, up to the maintenance department, very well know, we are the struggle. If the one pump or equipment to be failed means, what is the reason, why the reason? All the people surrounded me. So that's the time your maintenance people will struggle. That's the time we introduce the FIFO block in our DCS. This feature is reflect all the interlocks to be connected to the FIFO block. So FIFO block will reflect the which cause of the particular pin number to reflect the next page. So we can easily identify which cause of the reason to pin cause of the failure. So this block is to use the FIFO block in DCS. It's one of the troubleshooting for us. So next one, it's a case study of also the troubleshooting. In DCS, we have the IO cards, DI, DO and AIO, all the cards of DCS. It was connected to the all parameter equipment. It's related to the previous one, the FIFO. If bulk of equipment, a lot of equipment to be tripped any cause of the reason, it one kind of interlocks whether the DCS card failure. As instrument people, maintenance people, we know very well the DCS card failure, but it time to take much more, which card to be failure, which to be replaced, all the things to be time taken. That's the purpose we introduced the DCS card failure visual logic display. This page reflects the all cards, DCS all cards represent the one single page. So visual basic easily can view by that the green color reflect the card healthy and goodness. Red color here not available in the red color, but red color shown the card failure. Then white color reflect the dummy, no any card insert place. And the SP, the card inserted, but the no equipment connected, the spare indication. So if any bulk of group of equipment to be failed means apart from the FIFO block, we can easily identify the DCS card failure logic. We can easily implement the and change over the DCS card also very well. So these are the benefit of our DCS card failure changing. Quick time reducing is the downtime is reduced. So next, apart from the next slide, we have the troubleshooting one. He will explain and share the about things. My colleague, Mr. Sivakumar.
Thank you. We would like to share our implementation is last running status. In the pulp mill is where cooking, washing and bleaching plants. It has more pumps and equipments. The more pumps and equipments is one is running and another is standby for the continuous operations. In the past when there were, we are two or more equipment such as during operation is a shutdown, preventive maintenance and the occasional power failure, we will in dilemma which was in service. When the pump is operating correctly, is no issue. Otherwise, the pump is operating incorrectly, in unsafe issue like near miss or an accident and productivity loss and the unnecessary delay in restarting. To overcome this problem, we have developed a logic by last running of the equipment. We have given it to be displayed near the equipment on the DCS monitor. This is our one of the example is that two filters are available, one filters are running and another are standby. If any conditions such as like shutdown after restarting the equipment is we are dilemma which was in service. After this implementation is the last running is LR tag is available and near the equipment. So we are easily identified and easily operated with safely in the equipment. These are benefits. The benefits is enhanced safety and increased productivity and unnecessary time delay is avoided. And the next implementation is our pulp mill bleach plant is chemical optimization. Pulp mill is having D0, EOP, D1 stages. The chemicals is ClO2, caustic peroxide, oxygen and the ClO2 is necessary for the pulp mill bleaching. Is a chemical used in it. Previously, we are set the any chemicals, we set the set points by lab results and the visual appeal. The lab result will be available after few hours. So we not able to maintain consistent quality due to this manual interferences. To solve these problems, we are implementing the Max software with the way of Industry 4.0. In this software is included software sensors and the hardware inline sensors. The hardware inline sensor is bleach load transmitter to find the kappa number and the brightness. To bleach and the BT is brightness transmitter to find the brightness. The bleach load transmitter is located our D1 and D0 inlet stages, and the BT is located over the D1 reactor outlet stages. After implementation, we set the targets to change time to time when the current situation and the upcoming events based on the predictive model. Through this only feed the chemicals in only precious quantities. This provides the benefits such as cost reduction to the chemical overall productivity and the chemical reduced by the same targets and the consistent quality. And to summary, we are using the implementation ideas by the case study 1, gamma detector. By using the scintillation counters, we saved up to 45 lakhs, which is one-time investment. And the implementation of e-server, we access the real-time data in any time, anywhere with our industry plant LAN network. And another one, FIFO logic, the first in, first out, to reduce the troubleshooting time. And fourth one is DCS card failure logic to reduce the downtime and find the with card failure shortly. And the last one status, it is enhanced safety. And the fifth one, chemical optimization, is a cost reduction up to 550 lakhs per annum and path forward towards IoT. And automation is provide the promising opportunity to increase the overall productivity and the sustainability. Thank you, our session chairman and IPTA and management of SBB, our Honorable Director of Operations and CM Pulp Mill Operation, for giving us an opportunity to share our experience in this forum. Happy Papers Day to everyone on August 1. Thank you. Jai Hind.